equation balancing time. We have 2C plus O2 plus half N2 plus 5 halves H2 turns into, oh my goodness, H2N CH2COOH. Okay. And in terms of balancing, let's see what we've got here. It looks like it's actually already balanced. It just needs to be tweaked a little bit such that we don't have those fractions, right? Um, if we want to balance this, I mean, did these numbers, did you already have these numbers, or like just how to get rid of the fraction without messing with that crazy molecule on the right? That's the question here, basically. So, okay,
Uh,
go ahead.
yes. So I tried balancing the equation,
Mm-hmm.
but I ended up with fractions, so I had a hard time getting rid of the fraction
All right,
without changing the oxygen molecule.
I'll show you how to do that. To get rid of the
Okay, thank you.
fractions, easier than you think, multiply everything by 2. So coefficient of carbon was 2, it's now 4. Oxygen's coefficient was 1, it's now 2. Nitrogen's coefficient was a half, now it's 1, so we don't write anything. Hydrogen's was 5 over 2, so now it's 5. This, whatever thing, amino acid, glycine, I guess it is, will just now have a 2 in front of it. Easier than it may seem. That's it.
I almost had it. I pondered with the idea of just multiply everything with two, but I was like, well, that's going to change the equation on the right.
Yep.
I must have misread it incorrectly. Thank you.
Could have, yeah. And yeah, so sometimes it's like these small little like tiny things that set us into confusion. So cool. So yeah, that's all you have to do to finish balancing that is just multiply whenever you have a half fraction, just multiply everything um by that. So all right, so number
Awesome.
three.
Thank you.
Yeah, of course. All right, so write a chemical equation that forms this. Oh, okay, so we just did this. So let's take a step back then, and we'll go with Michaelis. So I think this is a good place to start. So starting with your elements, remember that oxygen, nitrogen, hydrogen are diatomic, and we make our glycine. And I totally get it's a pain in the butt to try and count these. If you really wanted, though, we could just say, okay, let's go ahead and condense this. Let's say, okay, how many H's do we have? We have two, two, one. That's 5 H's. And I'm just going to put them in whatever order. We don't really care for this. We have one nitrogen only. With carbons, we have 2 carbons. And then it looks like we have 2 oxygens. So if it helps you to kind of recondense this, this is kind of a structural formula, something more seen in OChem. And then if you just want to condense it to the elements, that's how you would do it. You would just count up, okay, how many hydrogens do I have altogether? Well, I have 5. How many nitrogens? 1. How many carbons? 2. Oxygens? 2. And now we can do our reactant and product idea. We see, okay, we have 1 carbon on the left, 2 carbons on the right. I guess I should write out what elements we're doing. With oxygens on the reactant side, we have 2. Oxygens on the product side, we have 2. Nitrogens, 2 and 1. And hydrogens, 2 and 5. And so I think Jesse had the right idea of balancing it. You'd put a 2 in front of carbon and then a half and a 5 halves there. That would be the best way to balance this. And then duplicate it from there. So, Michaela, does that kind of help if we condense the formula like that? I think a little bit easier to work with that way. But yeah, you'll see sometimes organic molecules are written more complexly. All right. And then if we want to go ahead and balance to say, okay, we need this carbon to be 2, so we'll put a 2 in front. Oxygens are already good. If we wanted, we could just double our glycine. That would be another way to do this. We could say, okay, we need 2 glycines now. By doing that, I'm going to mess with every other element as well. So remember, in order to get the number of the element, you'd have to multiply your coefficient by your subscript. And that's how I got 10 hydrogens out here. So the subscript tells you how many are in one molecule, and the coefficient tells you how many of that molecule you have. So we have 2 glycines. Each glycine has 5 hydrogens, so overall we have 10. And if we want, we're going to go ahead and fix the rest now. If we want to go back and fix carbon, if we need that to have 4, we can go ahead and make that a 4. If we need oxygens to have 4 as well, we can put a 2 there. That'll make us have 4 oxygens, because remember, coefficient times subscript. Nitrogens, we are good. Hydrogens, we need 10, so we can do that by making this into a 5. So, I guess in this way, I didn't even need the fractions. So, but you can kind of... What's up? Go ahead. Oh, I think she's got other things going on. Okay. Cool. Does that make sense, Michaela? And Jesse, I guess? So either of those ways will work. Alrighty, I'm going to try and launch the recording software. I have a recording on my phone of me trying to hold the phone in one hand and write on the tablet in the other, so it'll be fun. Okay, I'm gonna stop this one.